We started looking at inheritance by studying interfaces. So we defined an interface and a class can implement that interface. An interface is a contract and a class implements the interface by supplying implementations of each of the public methods defined in the interface. Then we also looked at subclassing. This is a different kind of inheritance where one class extends another class. The top class is called a superclass or sometimes base class, and the new class is simply called a class or sometimes a subclass. In this case, the class inherits all of the fields and public methods and private methods of the base class. For example, we looked at a turtle that is extended by class colorTurtle. ColorTurtle inherited the behavior of turtle, but it also added the ability to draw with colors. Today, we are going to look at how to mix up these two kinds of inheritance, subclassing and defining interfaces, sometimes called subtyping. If you recall, we already defined an interface vehicle that was implemented by a boat, a car, and a tank. And the tank class also implemented the weapon interface. So one class can implement multiple interfaces as long as it satisfies their contracts. And let's look a little more at this. So we had interface vehicle, and it had three methods that implementing subclasses had to implement. We made a class that implements vehicle called car. It had a registration, a constructor, a way of setting the registration in the constructor, a capacity, a getKind method, and a getRegistration method. So now I'm going to subclass class car. And I'm going to call it VW. So VW extends class car. And that means it inherits this field and all of these methods. Now, last time we said that a subclass needs to implement the constructors of the superclass. And here is a constructor that sets the registration for a car. Why is Eclipse and Java happy that VW does not have a similar constructor? A similar constructor to this car constructor that takes one argument. Well, that is because car also has this no argument constructor. And every class has, by default, a no argument constructor. And if this is present in the superclass, then the subclass do not have to do anything. It is as if there is an implicit constructor, VW, that simply calls the superclass. So this is tricky. It's not straightforward. The rules are a little complicated. But essentially, if a class has a parameterless constructor, its subclasses do not need to define constructors. If a class lacks a parameterless constructor, so let's take this out, and let's take the parameterless constructor in car out. So now class car only has a constructor with one parameter, and therefore the subclass VW needs to implement a similar constructor. It can't rely on the fact that there's a no argument constructor. So usually Eclipse and Java will warn us if we need a constructor. So we don't need to worry too much about that. Now, at the moment VW is exactly the same as car. It does nothing differently. But I want to override the getKind method so that it has different behavior. So I'm going to copy that and paste it here in VW. And when VW.getKind is called, I want it to return VW. Okay, right. Let's look at how we used vehicles last time. We had a main function that said vehicle V1 is a new car. And we could say that because car implemented the V1 interface. So V1 is a vehicle. And similarly for boat. Boat implements a vehicle interface, so it is okay to assign that reference to a V2 variable that is of type vehicle. And the same is true for VW. I'll just say that. There is no problem with this. I can display the details for V3. Java does not worry about this. But how is this possible? VW does not implement the vehicle interface. However, it extends car, so it inherits all the behavior of car. And car, since it implements the vehicle interface, so does VW. And that's why I can create an instance of VW and assign that to a vehicle variable or a vehicle reference. So let's just look at a little diagram of that. What I've done now is to say VW extends car, and since car implements vehicle, it's fine to assign an instance of VW to a variable of type vehicle, a reference variable. Moreover, VW has overridden the getKind method of class car. So it provides a new implementation for getKind. Let's see that in action. So here I have my original definition of car, let's say, and it implements vehicle. VW extends car, and it replaces the getKind method, but I did not show it here. And then in another class, I create a vehicle and I assign to it an instance of a new car, and I create a new instance of VW and assign that to a different vehicle. So let's see what happens. V1 is pointing to a new instance of class car. V2 is pointing to a new instance of VW. And now I call v1.getKind. Is this allowed? Yes, because getKind is a method that is promised in interface vehicle. All classes, all instances will have an implementation of getKind. That's what the interface demands. So it's perfectly okay to call getKind here and here. But which getKind is called? For V1, V1 points to an instance of car. So it's car's getKind that is called, and it will display car. This sends back a string that's equal to car. V2, when I call its getKind, it's the class VW's getKind that is called, and it returns a different string. It returns VW. So even though this program did not know exactly these two lines of code, they did not know exactly what kind of vehicle V1 and V2 are. They called the correct getKind method, because when getKind was called, Java looked at this class and called its getKind method, and it looked at this class and called its getKind method. There's a lot more to this, as you can imagine. We can make things more complicated or less complicated, but I want to show you something else, talk about something else. This is from the textbook. It's talking about the use of interfaces versus the use of subclassing. Now you can imagine subclassing is useful because we inherit all that code and behavior. We don't have to retype all the lines of Java. Similarly, interfaces are really useful because they guarantee a certain interface or contract that a class will satisfy without us needing to worry how it's implemented. So for clients, people who want to use the code without knowing the details, it is useful to have interfaces. On the other hand, for implementers, developers who have to write the code, subclassing is a useful way of saving work. It says here, the use of subclassing is controversial among systems programmers because its advantages over subtyping are debatable. What they really mean is that if I extend a superclass and that superclass changes, I may have to change my extension class as well. If car was changed dramatically, maybe VW would also have to change. And there is a name for this. It's called the fragile base class problem. However, despite this fact, subclassing, extending other classes, is used all over Java. It's everywhere, as are interfaces, but subclassing is definitely not a rare thing. For example, when we used standard draw, it made use of a frame that is a subclass extends class window, that extends class container, that extends class component, and ultimately component extends class object. We'll talk more about this class next time, object. But the fact is that subclassing and interfaces are equally important, and we have to understand both of them.